Welcome back to the classroom. My name is Mr. Wong. In today's lesson, we're going to go through a past paper question, again on friction and again about force vectors. So let's have a look. The image below shows a box with an applied force. You can see 400 newtons being pushed down at an angle of 20 to a 19 kilogram box. The static I'll say that again. The static coefficient of friction between the box and the surface is 1.2. The first part of the question, it says, determine the magnitude of the applied force along the x-axis. What that means is it's asking us to find the horizontal force being pushed along in this direction. Okay, now we have a force of 400 newtons and we know what the angle is, assuming that we have two perpendicular components of our resultant vector. This is the line we want to find. So this is fx, and fx is equal to our resultant vector, which is 400, multiplied by our trig ratio of the hypotenuse and the adjacent side, which is cos theta, and the angle of 20. So I put that into my calculator. That will tell me my horizontal force applied onto the object. And from there, I get a value of 375. And if I write out the full number, this is what I have. I'll just round off to 3 significant figures for now. Okay. So 376 newtons horizontally is the horizontal force I've applied. Next question, determine the normal force as the force is applied. Okay, remember, on a flat surface, so if I draw my box out again, on a flat surface, the normal force is equal and opposite to our gravitational force. Okay, effectively, the normal force is the amount of force of contact. Now, if you actually take into account the fact that we are pushing down on this object, so it's pushing it down like so, we have an increased amount of contact with the surface. So our normal force will be the opposing gravitational force plus the vertical component of that force being pushed down due to the 400 newtons of force we've applied. So our normal force is going to be mg plus our force component of Fy. Now mg is going to be, let's see what the mass was, 19 times 9.8 plus Fy, which we have 400 times sine 20. Now for those who are wondering why sine 20, if you can see that's the hypotenuse and that's the opposite side, so according to trig we're using sine theta. Okay, so let's put that also into our calculator and let's see what normal force we experience due to that. So 323.0080573. Again, if I round it off to 3 significant figures, it's 323 newtons. Okay, so that's my normal force there. Okay, question C. Determine and justify if the applied force is adequate to move the box. Okay, so this is when we talk about the applied force, we're saying, can we overcome friction? So is the applied force bigger than our friction force? Now, let's look at how we calculate friction again. To calculate friction, it's friction force equals to the coefficient of friction. In this case, we have the static friction and then the normal force. Static friction is 1.2. Okay, so what we have is the calculation for static friction. Whoops, I wrote kinetic friction there. So static friction is 1.2 times our normal force, which is 323.0080 multiply that together, and so the friction force we need to overcome is roughly that number here, or exactly that number here. So approximately 388 newtons. Okay, let's look at what our horizontal force was. You can see our horizontal force here is just slightly below our friction force. So force of X is smaller than our friction force. Our horizontal force was 300 and that, which is smaller than 388. So what we can conclude is if our horizontal force is smaller than the maximum static friction force, then we have no motion. So horizontal force, I'll just word it a little bit more eloquently. Horizontal force is smaller than max static friction force, hence no motion. Okay, so that's what we have there. Okay, let's move on to the next question. So, question D, it asks, explain how changing the angle of the applied force could change the outcome. Obviously, the outcome we're looking at is obviously to have motion. So we want to generate an angle that could increase that motion there. So what we'd aim for is if we're changing the angle, we want to actually decrease theta. So we want theta to go down. Why is that the case? If I actually try and draw this out here, we have the box. This is 20 degrees. This is, what number do we have? 400, I think it was. 400. And then if we swap this around and we have it, you know, let's say we're pushing this box directly horizontal, so the angle is 0. So originally we said that the horizontal force is 376. If we're pushing it directly horizontal, then there is no vertical force. All the force of that is horizontal, and you can see that now we've actually increased the horizontal force pushing the box along, and we said that the maximum friction force was 388. So if I have it horizontally, or if I lower the angle to the horizontal, I would get motion, okay? So that's how I'm going to actually change it. So to make the object move, as that is the outcome, or that is the different outcome, if you said to increase the angle, that wouldn't change the outcome. The box would still not be moving. The angle of the applied force needs to decrease from the horizontal plane. This increases the horizontal force and as a consequence, Fx would increase the horizontal force. Whoops, that's pretty much it. So that's an explanation of the horizontal force. And let's actually look at how we could maybe expand it a little bit more. because this is a pretty sort of straightforward explanation here. But as we know, the horizontal force is 400 times cos theta. And what we actually know is as theta goes to 0, okay, cos theta goes to 1, or what we could say is its max value. And then what we can claim is, therefore, force, the horizontal force, can become or get closer to 400 newtons, and thus be larger than the friction force. Increases the horizontal force, making it larger than the friction force. Okay, so let's just break down how we answered this question. Firstly, we claim that the object will move if the angle was to decrease. And we showed if theta goes to 0, cos theta becomes 1. And as a consequence, fx will equal to 400. So if our horizontal force is larger, that means we are able to overcome the friction force, allowing our object to move. It was quite wordy, probably more wordier than it should be for a 2-mark response, but that's how we go about it. So hopefully that was useful and you found it easy to understand. Hit the like and subscribe button to support more videos to come in the future. Take care.